Okay, so today we'll start with common roots. Suppose we have a quadratic equation, ax squared plus bx plus c equal to 0. First case I will take when one root will be common. Case 1. If one common root. If one common. Suppose we have two quadratic equations, a1x squared plus b1x plus c1 equal to 0 and a2 x squared plus b2x plus c2 equal to 0. We have these two quadratic equations. And they will have roots. So one root has to be common. So suppose roots of first quadratic equation is alpha and beta, and roots of second quadratic equation will be alpha and gamma, because no one root we have to keep common. Okay. Now we have to find the condition. Like whenever you are asked, suppose these two equations have one common root, then find the condition on alpha or beta or for any variable. Then how will you solve that? So we'll derive that condition and we'll remember that. See, alpha is root of both the equations, right? So put here. So alpha will satisfy both the equations. So like that. A1 alpha square plus B1 alpha plus C1 equal to 0. And A2 alpha square plus B2 alpha plus C2 equal to 0. Now solving for alpha. How will you solve this? See, there is a unique way to solve this. You must have studied about this in lower grade, like class 9, class 10. So alpha square, here it is alpha. So just put minus alpha. And then this is constant term. So just put 1. Equal to equal. Alpha square in the denominator of alpha square. Just hide this thing. Hide the coefficient of alpha square and write this B1 C2 left to right minus B2 C1 minus alpha in the denominator of this. Hide alpha, hide this term, alpha, terms of alpha. And this will be A1 C2 minus A2 C1. And here we have constant term, for that we use 1. Hide this constant term and write A1 B2. You always have to start with left to right. A1 B2 minus A2 B1. Now, from these two, we can find alpha will be cancelled. So alpha can be written as from these two minus and then B1 C2 minus B2 C1 upon A1 C2 minus A2 C1. And from first and third, we can write alpha square as B1 C2 minus B2 C1 upon A1 B2 minus A2 B1. Now, just replace the value of alpha here. Put the value of alpha here in this equation. Put this square of this minus will be gone. So B1 C2 minus B2 C1 upon A1 C2 minus A2 C1 whole square. This is B1 C2 minus B2 C1 upon A1 B2 minus A2 B1. This term will be cancelled out here. So B1 C2 minus B2 C1 upon A1 C2 minus A2 C1 whole square equal to 1 upon A1 B2 minus A2 B1. Cross multiply this A1 C2 minus A2 C1 whole square equal to B1 C2 minus B2 C1 into A1 B2 minus A2 B1. Now, this is the condition when two equations will have one root common. So this looks little scary, or how to remember this. So I'm telling you the trick. See, this is the first equation. and this is the second equation. So just write the coefficient here. A1, B1, C1, A2, B2, C2. See, what is this? A1, C2, longer diagonal, minus A2, C1. So A1, C2 minus A2, C1 whole square, and then smaller diagonal, A1, B2 minus A2, B2. A1, B2 minus A2, B1, and then B1, C2, and then B2, C1. That's how you can remember. And this is the condition of one common root. Understood? Note it down. You noted, Archit and Ayushi?
Yes, sir.
Sir, 1 minute. Done, sir.
Archit noted?
Yes, sir.
Okay, now second, okay, now understand one more thing here.
और उसमें
So there
नीचे
is
वाला
one
नहीं लिख
more.
रहा था, वहाँ ऊपर तक ही लिखा था जहाँ तक आपने दिखाया था.
कहाँ तक? ये सब नहीं लिखा,
लास्ट की 3-4 लाइन लिखनी है.
ये लिखना है,
हाँ.
नोट करो. Shreya has come, right? Okay. Videos. Turn on your videos. Both Ayushi and Shreya. Archit, you again have to join at 7 today.
ओके सर, ओके सर.
Integration, I'll take integration for 12th class.
ठीक है. डन सर.
Okay. Now, see, there is one more way to find the common roots. See, you have, this is also very important. Suppose you have two quadratic equation, a1x square plus b1x plus c1 equal to 0 and a2x square plus b2x plus c2 equal to 0. And its roots are alpha and beta and alpha and gamma. So alpha is the common root. So how will you find the common root? So what you have to do is, you have to uh, make the coefficient of x square same for both the equations. How? Just divide it by a1 so that you will have x square plus b1 a1 x plus c1 upon a1 equal to 0 and then divide this second equation by a2 so that you will get x square plus b2 a2 x plus c2 by a2 equal to 0. Wait. Now, see, we have to make the coefficient of x square same in both the equations and then subtract. Then subtract these two equations. Subtract. We will get b1 a1 minus b2 a2 x plus c1 by a2 minus c2 by a2 equal to 0. So from here, whatever value of x you get, that is your common root actually. So you have to remember this. And now, how will you find other roots? So for this, like if you use the sum of the roots or product of the roots, so in any one of them, if you put alpha, you will get beta. Same thing you have to do here, right? So this is the way to find common root by making coefficient of x square same and then subtracting it. You will get the value of x, that is your common root. This is important. Noted then.
Yes, sir.
Now, case 2. If both roots common, suppose a1x square plus b1x plus c1 equal to 0, a2x square plus b2x plus c2 equal to 0. If these two equations have both the roots common, if these two equations have both the roots common, it means that their coefficients are in proportion. It means that their coefficients are in proportion. So we write that ratio coefficient of x square must be equal to ratio coefficient of x must be equal to ratio coefficient of ratio of constant term. Correct? Done? Okay.
Yes, sir.
Yes.
Now, see, suppose you have two equations, a1x square plus b1x plus c1 equal to 0 and a2x square plus b2x plus c2 equal to 0. Suppose if any of the equation has imaginary root, means alpha plus iota beta, and if one root will be common. So this equation will also have this root because one root is common, and if that root is imaginary, then you know that imaginary roots always occur in pair. So its another root will be its conjugate, and here will be the same thing. So if any of the equation has imaginary root, it means that both the equations will have both roots common. If any of the equation has one imaginary root common, one imaginary root in common, then there both roots will be common. Both roots will be common, because we know that imaginary roots always occur in pair. And same goes with irrational root. Suppose first equation has one irrational root, and both the equations has one common root. So this equation will also have this irrational root, and we know that irrational root always occurs in pair. So other root will be p minus root q, and here will be the same thing. So again, if any of the roots will have imaginary or irrational root, then irrational root in common, then their both roots will be common, and we'll apply that formula condition a1 by a2 equal to b1 by b2 equal to c1 by c2. So this is all about condition for common roots. Done. Now see, now let's take some question. Question is, determine the values of m for which the equations 3x squared plus 4mx plus 2 equal to 0 and 2x squared plus 3x minus 2 equal to 0 may have a common root. Now see, we have equations.
So what
Yes,
is the first line? It is getting cut off for me.
determine the values of m for which the equations.
Okay.
See, if both the equations would had variable as coefficient, then we had to use that initial condition that we derived, first condition. But this equation does not have any variable coefficient, so we can try to find the roots of this equation. So first, we can see that if you find d, then d will be positive, right? B square minus 4ac. So it will have some real roots. Now we'll apply the same thing. See, 3. So see, find b here. B square minus 4a and c. So this is 25. That is positive value. So this will have two real roots. So 3, 4m, 2. And then 2, 3, and minus 2. Which sign will take? Longer diagonal. 3 into minus 2. Minus 6, minus 2 into 2. 4. And then whole square. This is smaller diagonal. 9 minus 8 m. And then 4m minus 2. That is minus 8m and minus 6. So this is 100 equal to 9 minus 8m and then 8m plus 6 with a negative sign. So just consume this negative sign. It will be 8m minus 9 and 8m plus 6. Multiply this. This will be 64m squared. 48 minus 72. That is 24. 72 minus 48 is how much? 24 m minus 54. So you will get 64m squared minus 24m and minus 154 equal to 0. Now solve this. You will get the value of m. So this is minus b plus minus under root b squared. Oh, this is going to be a very big number. Okay, no problem. B squared. I'll tell you other way as well. Minus 4AC by 2A. You just have to solve it and then you will get the answer of n. But this is going to be little lengthy, right? I'll tell you another way. First, you note it down. Mhm. Noted? Now see, this is going to be little lengthier, right? So we'll try another way. How? See, we can find the roots of this equation, right? So find minus b plus minus under root b square minus 4ac. So if you take c will be minus 2, so that will make it positive upon 2a, that is 4. So this is 5. So minus 3 plus minus 5 by 2. So roots will be either minus 2 or half. See, we have two roots for this equation, either minus 2 or half. And both the equations have common roots. So maybe like, minus 2 will be common root or maybe half can be common root, right? So if minus 2 will be a common root, then of course this will satisfy this as well, because if this is the common root, so this will be the common root of this as well to satisfy this. So 3 into minus 2 whole square plus 4n into minus 2 plus 2 equal to 0. This is 12 minus 8n plus 2 equal to 0. You will get m as 14 by 8, that is 7 by 4. So one value of m could be this. And if half will be common root, will be common root, so half will satisfy this equation. So this is 3 upon 4 plus 2n plus 2 equal to 0. So 2n can be minus 11 by 4. So m will be minus 11 by 8. So that's how we can find the value of, sorry.
अच्छा नहीं कुछ नहीं
So that's how we can find the value of m.
Done, sir.
Hmm. Now question for you guys. Solve this. You have to solve it.
Sir, could you please drag the picture a little down?
All
Thank
right.
you, sir. Yes, sir. Done or not? Not yet.
Sir,
Sir, 1 minute.
Hmm. Got the answer or not? See,
सर क्वाड्रेटिक आ गई, बस वो रूट्स निकाल दो.
okay. See, if the equation this and this have a common root, so we'll apply the same concept, then find the real values of r. Now, in this case, both the equations has variable coefficients, so we cannot find roots in any of for any of the equations. So we have to apply that concept. Take the coefficient of both the equations like this, and then 1, 2, and 2 alpha, and just apply that condition of having one root common. That is 2 into 2 alpha minus 1 into alpha whole square equal to 2 into 2, 4 minus 1 into alpha. And then alpha into 2 alpha, that is 2 alpha square minus 2 into alpha. That's it, finished. 9 alpha square equal to, multiply this, 8 alpha square minus 8 alpha minus 2 alpha cube plus 2 alpha square. So bring all the terms to left. So this will become 2 alpha cube, 9 alpha square minus 8 alpha square, that is alpha square. And this is also 2 alpha square. So finally it will come here and it will make it to negative. And this 8 alpha will come here and like this. You can take alpha common. So this is 2 alpha square minus alpha plus 8 equal to 0. So either alpha can be 0 or 2 alpha squared minus alpha plus 8 equal to 0. You can see, if you find discriminant of this quadratic, this is b squared minus 4a and c. Discriminant is negative, so no roots will be real, right? So no alpha exists here. So alpha has only one value, that is 0. So this is your answer.
Sir, I
Hmm.
got this answer, but I thought it was wrong.
Now, why are you thinking that way? Whatever answer you get, just like be confident and share with me. Don't worry about it will be wrong or right. Note it down quickly.
Done, sir.
Everyone done? Shreya, Archit, you both
Yes,
done?
sir.
Okay. Now, next question would be, see this question I'll solve. Don't worry. See, question says that equation this and this have common roots. Have two common roots. See, two common roots. So these are cubic equation. So they will have three roots. So two of them are common. So both will have one uncommon root as well. So alpha cube, x cube plus 4x squared plus px plus q equal to 0, and then x cube plus 6x squared plus px plus r equal to 0. So alpha and beta are common to both. As you suppose gamma is the third root and delta is its third root. So only they have only two common roots. Now do one thing. Remember this thing. Now subtract these two equations. Subtract these two equations. So after subtracting, this x2 will be cancelled. And now you will have minus 2x squared and plus q minus r equal to 0. So now this equation will give you the common roots. When you see, you have two equations in cubic, in 3 degree, they have two common roots. So once you subtract them, x cube will be cancelled and you will get equation in 2 degree, quadratic equation. And that quadratic equation will give you the two common roots, alpha, beta from here. By subtracting it, you will get alpha and beta. So remember this. So from here, you can see this is 2x squared and plus r minus q equal to 0. Now, alpha, beta are the roots of this. So alpha plus beta you can find, that is 0 because there is no term of x. Now you can see from here, in cubic equation, I already told you how to find the sum of the roots. So alpha plus beta plus gamma you can find minus b by a, that is minus 4. And from here you can find alpha plus beta plus delta, that is minus b by, that is minus 6. Alpha plus beta equal to 0, that you found. So from here you can find gamma is minus 4 and delta is minus 6. So you have to find the equation found by their uncommon roots. So with the help of gamma and delta, you have to find the equation. How do you find? X squared minus sum of the roots into x plus product of the roots. So x squared, if you add it, minus 10, minus minus plus, it will become 10x plus 24. This is your answer. Understood?
Yes, sir.
Hmm. Note it down. Done. Next question. Try this. Okay, did you understand like how to solve this? See, question says that if one of the roots of the equation ax squared plus bx plus c equal to 0 be reciprocal of one of the roots of this. Suppose its one root is alpha and other root is beta. Its other root will be 1 by alpha and its roots will be 1 by alpha. Okay, see. So the question says that suppose like this equation has one root alpha and it has one root 1 by alpha. So the root of one equation is reciprocal of one root of other. So see, alpha will satisfy this equation. So a alpha square plus b alpha plus c equal to 0. Now 1 by alpha is root of this equation. So 1 by alpha will satisfy this. b1 1 by alpha plus c1 equal to 0. If you simplify this, you get c1 alpha square plus b1 alpha plus a1 equal to 0. Now I can say that these two equations, this equation and this equation has one root common, that is alpha. So let's apply the formula a into c. A, B, C, C1, B1, A1. A into A1 minus C into C1 whole square equal to AB1 minus BC1 into BA1 minus B1. That's what you had to prove. Understood?
सर C1 अल्फा स्क्वायर प्लस B1 अल्फा प्लस C1 कैसे है?
मतलब इसका just take LCM ना here, because 1 by alpha is the root of this equation, so alpha will be root of this equation after taking LCM.
Then
Everyone done? Next question. Try this question. Try this.
Sir, is the answer 3?
सर आंसर क्या है?
3. See, this is
सर आप म्यूट हो.
Sir, you're on mute.
okay. Sorry. So apply the condition of 1 common root a into c minus b into b, b square, and then b into a, ab minus c into c. That is c square. Let's solve this. So you'll get a4 plus b squared c squared minus 2 a squared bc equal to a squared bc minus a c cube minus a b cube plus b squared c squared. Let's try to solve this. You'll get, see, b square c square gone, and then a4 minus, bring this to this side. So this is 3 a square bc, this is plus ac cube, and this is plus ab cube equal to 0. Take a common, a cube plus b cube plus c cube minus 3abc equal to 0. A can't be 0. If a will be 0, this won't be any more quadratic equation. So a can't be 0. A can't be 0, so this has to be 0. So a cube plus b cube plus c cube minus 3abc will be 0. So take this to right and divide this by abc. So this is your answer 3. Right. This is number 1.
Sir, is my method correct?
Which method? You said that was super shortcut. Super shortcut. And this is 100% incorrect. Okay. This is incorrect.
Okay, sir.
Note it down.
But sir, why is it not correct?
You cannot take A equal to B equal to C always, no. If you take A equal to B equal to C, in that case, both, all are same. So both equation will be same. So both roots will be common. Question says that only one root has to be common.
Okay, okay. Yes, yes, sir.
Let me know once done. Noted, guys?
Yes, sir.
Now, let me tell you one more way. Method 2. See, you can observe one thing. Method 2. Question says that these two equations have one common root. So, if suppose alpha is the root, suppose alpha is the common root. So, no, don't think like that. See, both the equations has one common root. So if you carefully observe, you'll find that if you put x equal to 1 in first equation, you get x a plus b plus c equal to 0. And if you put x equal to 1 in second equation, you again get same thing. It means that x equal to 1 is the common root. X equal to 1 is the common root. And you have a plus b plus c equal to 0. And you know the formula of a cube plus b cube plus c cube minus 3abc equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. ABC is 0, so this complete thing will be 0. So a cube plus b cube plus c cube equal to 3abc. So whenever you have a plus b plus c is 0, you can always write a cube plus b cube plus c cube equal to 3abc. So this upon this is 3ab. So this is how we can solve it. But for that you have to. So it will that in that way you can think, but after a lot of practice, you have to do practice. You have to practice and start solving Senges, everyone.
Sir, we can also say that if a plus b plus c is equal to 0, and then we can substitute a as minus c minus b.
Why do you want to complicate this? Okay,
It was not quadratic, but it
don't
was an
complicate.
identity.
Who told you that this is identity?
Uh, I have to search it, but it was there. I'll search it.
Search it on Google.
No, sir,
Don't
it was there
search
in the
it.
book, but it.
Solve this question. I mean, you cannot solve it. I know that, but at least try. Give it a try. Think for a minute and then I'll solve. Any suggestion that you want to suggest to solve the question? Archit, Ayushi, Shreya.
सर PQR में कुछ पैटर्न तो है, मतलब मे भी कॉमन ले लेंगे.
See, I'll tell you. You have to prove that roots of this cubic equation are real. Do one thing, just put the value of PQR here. So P is A1 plus A2 plus A3 plus A4 plus A5 plus A6 into x square, and Q is this thing, A1, A3 plus A3, A5 plus A5, A1 plus A2, A4, A4, A6 plus A6, A2 into x and minus R. R is A1, A3, A5 and minus A2, A4, A6 equal to 0. Now do one thing. Just separate terms. How? See, this is 2x cube. So take 1x cube and then take, see, you have A1 into A3 into A5. So take these terms, A1, A3 and A1, A3 and A5 into x square, and then A1, A3 plus A1, A5 and then A3, A5. A1, A3, A3, A5 plus A5, A1 into x minus A1, A3, A5 together, and then again plus another x cube minus A2, now A2, A4 and A6. A2, A4 and A6 x squared, and then these three terms. This is A2, A4, A4, A6 plus A6, A2, x, and then in last A2, A4, A6 equal to 0. Now you can see one thing. This looks like this is the cubic equation having roots A1, A3, A5. X cube minus sum of the roots plus sum of the roots second two at a time minus product of the roots. I already told you this in the beginning. So this is the cubic equation having roots A1, A3, A4. So this can be written as x minus A1 first root, x minus second root, and x minus third root plus. And again, same thing here. This can be written as x minus A2, x minus A4, and then x minus A6 equal to 0. Now, see, we have to use this information. A1 is bigger than A4 is bigger than A3 and like that. So for that, what we will do, we'll simply assume this as a function of x. Suppose this is your function fx. This is your function fx. Now we have to find, we have been given this. A1 is more than A2 is more than A3 is more than A4 is more than A5 and more than A6. How will I use this? See. What I'll do, I'll find f of A1. Put x equal to A1 in this equation. So A1 minus A1 0, complete term will be 0, and here we'll have A1 minus A2, A1 minus A4, and then A1 minus A6. You know that A1 is the largest value. So this is positive, and this is positive. So this is positive. And then f of A2. So again, this will be 0 now in this case. A2 minus A2, we have this thing. So A2 minus A1, A2 minus A3, and A2 minus A4. You can see that A2 is bigger than A3. So this is positive. A2 is bigger than A5. So this is also positive. But A2 is smaller than A1. So this is negative. So negative positive, positive. So finally it will be negative. Now A3. So A3, this complete thing will be 0 because A3 minus A3 is 0. So here we have A3 minus A2 and A3 minus A4 and A3 minus A6. Now you see A3 is bigger than A4 and A6. So this is positive, but this is smaller than A2. You can see. So this is negative. So this is again negative. Right? A4. So A4, this will be 0 now. So A4 minus A1 and then A4 minus A3 and A4 minus A5. You can see A4 is smaller than A1. So this is negative. A4 is smaller than A3. So this is also negative. A4 is larger than A5. So this is positive. So this is the positive, negative into negative. F of A5. So F of A5 means this term will be 0. This term will be 0, A5 minus A5. So we'll have this term. So A5 minus A2 and then A5 minus A4, A5 minus A6. A5 is smaller than A2. So this is negative. A5 is smaller than A4. This is also negative. A5 is larger than A6. This is positive. So finally, negative into negative, positive into positive. Positive. F of A6. This will be 0. A6 minus A6. We have A6 minus A1, A6 minus A3, A6 minus A5. A6 is the smallest value. Negative, negative, negative. So this is negative. Now you see one thing. Just draw a number line. A6, A5, A4, A3, A2, A1. A1 is the largest value. So between, see, value of this function at A1 is positive. So function will be, graph will be somewhere here. And value of function at A2 is negative. So graph has to come over here. A3 is also negative. So somewhere downside. A4 is positive. So somewhere upside. A5 is positive, somewhere upside. And A6 is negative, somewhere downside. You know that quadratic equation is always continuous function. I mean, continuous means there is no break anywhere. So if graph will be something like this, not quadratic, any polynomials, my bad, it is 3-degree equation. So any polynomial will be always continuous function. So there won't be any gap in the graph. So here graph will be upward, above x-axis, and suppose graph comes like this. So in that case, at A1, the value of function has to be positive, but actually the value of function has to be negative. So function has to directly come like this. Then only it is possible to have negative value. Again, for A3, graph will go somewhere like this. For A4, it has to become positive. Graph will go up, again up, positive, and then graph has to be negative, so it will come down. So you can see that this is your x-axis. Graph is intersecting x-axis at 3 points. So of course, it will have 3 real roots. And this is cubic equation. So of course, they will have all 3 real roots. All 3 roots are real. समझ में आया?
Yes, sir.
Note it down.
Sir, could you please scroll down? Sir, I want to see the graph. Done, sir.
Noted, guys, everyone? Everyone noted?
Yes, sir.
Shreya, Ayushi,
Yes, sir.
Yes, sir.
next question. Try this. This is again the good question. So what do you think? Will you be able to solve this, or shall I start?
Sir,
See,
I'm not getting.
okay, see, I'll solve. Don't worry. It says that, question says that beta plus cos square alpha and beta plus sin square alpha are the roots of this equation. So x square plus 2bx plus p equal to 0, it has two roots. Beta plus cos square alpha and beta plus sin square alpha. And this are the roots of this equation, like x square plus 2bx plus c capital C equal to 0. So gamma plus cos raised to 4 alpha and gamma plus sin raised to 4 alpha. See, uh, and in the and like we have to prove this, and there is no term like beta and gamma. So we can think like, see, if suppose we have any general quadratic equation in this form only, suppose 2bx and plus c equal to 0, and it has two roots, let's say a1 and a2. So sum of the roots would be what? Minus b by a, and product of the roots would be c by a. See, these are the roots, right? So if you add, if you put here a1 is like this and a2 this, so beta plus beta, 2 beta, gamma plus gamma, 2 gamma. But you do not need beta and gamma. So do one thing. Find the difference of roots. That is a1 minus a2 whole square can be written as a1 plus a2 whole square minus 4a1 into 8. Right? Okay. Now, do apply this for this first and then this first. So see, A1 is this and A2 is this. Put here, beta, beta will cancel. And now it will be like cos square alpha minus sin square alpha whole square. And sum of the roots is minus 2b by 1. That is whole square. So 4b square minus 4 small c. So see, cos square theta minus sin square theta is what? Cos 2 theta. So this is cos 2 alpha. So cos square 2 alpha is 4b square minus c. This is your first observation. Now, do same thing for this. This is your A1 and this is your A2. Put here in this equation. So gamma gamma will again cancel. Cos 4 alpha minus sin 4 alpha whole square. This is sum of the roots. That can be given as minus b by a. So that is minus 2b. So this is 4b square minus 4 product of the roots. That is c by 1. So capital C. Now you can see that you can write this as cos square alpha plus sin square alpha and then cos square alpha minus sin square alpha. This is whole square. 4 d square minus 4. This is your one, sin square theta plus cos square theta. And this is again cos 2 alpha. So cos square 2 alpha equal to 4 d square minus capital C. This is your another observation. This is also cos square 2 alpha. This is also cos square 2 alpha. So this must be equal to this. 4 is common. So b square minus c is equal to b square minus capital C. So bring this to this side. Capital C minus small c equal to b square minus b square. That's what you wanted to prove. Right? Understood?
Yes,
Note
sir.
it down. Note it down. Let's have one more question. Find the condition on A, B, C, and D such that equations 2a x cube plus bx squared plus cx plus d equal to 0 and 2a x squared plus 3bx plus 4c equal to 0 have a common. I will try.
सर ये ऐसे पॉसिबल है कि अगर हमारा ए जीरो हो जाए तो फर्स्ट वाली तो वो
No, no. See. We have two equations, one cubic and other quadratic. Right. And they have one common root. So suppose alpha and alpha are the common roots. So alpha will satisfy this and this both. So 2a alpha cube b alpha squared plus c alpha plus d equal to 0. This is 2a alpha squared plus 3b alpha plus 4c equal to 0. Now subtract. No, don't subtract it. Multiply this equation by alpha and then subtract it. This gone. So b alpha squared minus 3b alpha squared. This is minus 2b alpha squared. C alpha minus 4c alpha. That is minus 3c alpha and plus d equal to 0. Now see, this is another quadratic equation. This is also quadratic in alpha and this is also quadratic in alpha, right? So this equation and this equation will have that root, one root common alpha. Now you apply the condition of one common root. So for this, coefficients are 2a, 3b, 4c. And for this is 2b, 3c and minus 2. Long diagonal, that is minus 2ad minus 8bc whole square equal to 2a into 3c, that is 6ac minus 6b square and then 3b minus 3bd minus 12c square. This is the condition that will exist. Understood?
yes
Note it down.